Good morning, and thank you all for joining us today. My name is Rashmita, and I'm the event planner for Microsoft Reactor Bengaluru, India. This session will run over the next 120 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Shivam, our speaker for today's session. Shivam is an author, cloud architect, speaker, and co-founder at TechScalable. He is passionate about technology and works on Azure, GCP, machine learning, and blockchain. He is also a Microsoft certified trainer. But for now, I will hand over to Shivam to begin the session. Over to you, Shivam.
Thank you. Thank you, Rashmita. I'll just quickly share my screen. Okay, so good morning, everyone. Hopefully, all of you are doing well. You are safe at home, and let's get started. So, we will be talking about how can we modernize the applications by using data and AI, or and which Azure services will be able to do that or help us out in doing that by understanding one customer scenario. So we'll go through one customer case study, and that case study is about one company called as Wide World Importers. And this Wide World Importers will be having a problem statement, and then few objections over there, and few requirements as such, which we today have to solve for them. So we all will be, you can say, we will be interacting and we'll try to solve it out for them. And along with that, once we do it, we will be covering the agenda which we have, which you have seen over here. That what is, how do you do, what is the meaning of ACR, virtual machines, IoT hubs, function app, Cosmos DB with Synapse Link, what is analysis services, what is Synapse analytics itself, ADLS, AML, AKS, what is Event Hub, how does it work, how what's the purpose of it, what's the difference between Event Hub and IoT Hub, and so on and so forth, right? What is stream analytics, what is the meaning of Postgres, Hyperscale, and what is and the problem statement of wide world importers, and then the architecture of it, like the converted architecture of it. And so we are also providing you with the further learning link over here. If you go to that page, basically that page will lead you to another. If you just go to that page, you will be able to find the GitHub link over there, which will be looking something like this. So I'll just open it for you like this. So this is where the case study is deployed, or the case study is available, and where the customer scenario is present, and we will be going through this customer scenario. We'll go through it first. We'll have a look at it, and then we'll see how are we trying to solve it. And just to show you that the solution is going to look something like this. So once we are able to understand what they don't have, and what are they doing, then how do you do this in the cloud platform? And then the that particular GitHub page which I was showing you, that GitHub page is also having step-by-step instructions for you to deploy the end-to-end scenario. It may take you a few hours to do it, maybe 4 to 5 hours to do it, but it's pretty interesting, and it's end-to-end, and it's very near to the real production scenarios. So I recommend that after the session itself, you can go and deploy the entire architecture. So what I have done is I have most of the architecture already deployed, because it will take a longer time for it to deploy. But I will walk you once we understand the problem statement, once we understand the solution of it, right? Then we will go through each and every individual component and we will see the details of it. And if there is anything which is very specific, or if there is something which is very important for us to know, or if there is something which is very important for us to maybe uh, maybe in future, maybe it's something which is very common, all the customers are asking for it and so on and so forth, right? So those type of things I will tell you on the way itself. Okay, so let me just first go through the case study first, the customer problem statement. Let's go through that. So okay, now I'll summarize it. It's gonna be slightly longer to read, but I will definitely see if I can summarize it for you. Okay, so the scenario is of wide world importers. Sorry. So of wide world importers, and they have manufacturing plants throughout the world as such. Now they offer different type of SKUs, more than 9,000. SKU will be the stock keeping units as such, and they have specific manufacturing execution systems are there. So uh, specific, you can say, specialized machinery for some work as such. Now they have 5 factories right now, and these 5 factories have around 10,000 sensors in each factory itself. So we have 50,000 sensors which are streaming the data in this point in time. So this company was not using cloud earlier, right? They were totally were on-premise as such. So they used to use Kafka clusters to collect the data coming from all these sensors, and then it was processed by one consumer application, custom consumer. Basically, consumer is the one which is sitting behind the Kafka consuming. It's a consuming application as such. Now the and this application is the one which is built with monolithic approach, and they are facing problems that when they are trying to scale, or that is becoming bottlenecks one of the bottleneck out of all of them. So okay, now they have an event data store that currently is running on Postgres, and everything is on-prem. A web app connected to data store reports the status on the factory floor. So they also are looking for some sort of interface, or the website or web app where they can see the real-time reports. So we have Power BI with us. We have Power BI can be embedded into Azure web app. So that part also we can see, right? Now okay, few of the problem statements. They are running into scalability issues as they add as when they're adding the manufacturing, increasing the manufacturing capacity, and when they are purchasing more, they are putting in more IoT sensors. Then the scalability is something which is not happening properly. Okay, now they are also asking that, okay, can we implement something like microservices? Can we implement something like event sourcing? What is event sourcing? They may also ask that. And can we implement something like CQRS patterns as such? So can we break the CRUD operations into maybe into different microservices? Reads are taken care by different microservice. Uh, Other operations are taken care by different microservices. So segregate them. Event sourcing will be, for example, if you let's say you get the data, you read the data from data store, and you did transformations on top of it, and then you wrote the final state back. So if you do not have any system, maybe another parallel system, or maybe another system which is inbuilt in your database, then if you don't have that, then the problem is that the intermediate state changes, or the intermediate history of the changes are lost. So that is something which we can take care of with the event sourcing mechanism, which basically means that things are immutable and we work with events. We read from one, we do few operations on it, and then uh, we are able to put it back again uh, into another, you can say, container. Maybe container will be like an MongoDB container, or Cosmos DB container. We'll see what is the meaning of that. So event sourcing can help us in making sure that the we are just not only storing the last or the most recent state of the data. We know the history of the changes as well. Okay, so the benefits of the clouds. They want us to ensure that they can manage the hybrid solution in a consistent way across on-prem and cloud. This is something which is pretty much coming over there. Okay, the needs of the customer. So they want us to centralize the factory sensor data into cloud using PaaS solutions, right? We have to replace our that's one of, let's say you went to this customer and they're literally telling it to you in like one-to-one conversation right now. So we want to replace our local installations of Apache Kafka with a service that does not require on-premise administrators to be there. Not all our factory will have dedicated Kafka administrators, which will lead to issues later on. The consumer group application we have built to process data from the Kafka is a data pipeline bottleneck. And when factory managers needs to, they literally need to wait for the information to come in. It is typically because the consumer group has fallen behind. Consumer application is not able to to process data with the same pace the Kafka is ingesting in that point in time. Okay. Now, factory floors are spread throughout the world. They would like to have some sort of mechanism to get the near real-time responses from the web application hosted on on-premises servers. So this near real-time request as fast as possible, uh, least latency solutions. Uh, these are few of the keywords we have to think about. Okay, instead of pure cloud-based solution, hybrid will be more suitable, and like that. In addition to storing data in the cloud, we would also like to integrate ML into the application processing. So they want us to detect the anomalies in the sensor data. They want us to predict when the machine is going to fail. So that particular maintenance is required based on the sensor data. And we have so in Azure we have custom and pre-built AI solutions. We are going to use both of them. So we will see where we can use which one and where we can say reduce the efforts and we can use something which is pre-built. If possible, then why to reinvent the entire wheel? Use something which you already have. So that is some we will be going through that. Okay, few of the objections which you have to help me in answering is we process a very large amount of sensor data at every factory. Will a cloud service be able to keep up with our data requirements? So are they scalable? Do they have partitioning capabilities? Can we have them in distributed manner? Can we maybe scale up, scale down, scale out, scale in, like that? What are the capabilities? Which one should we go for? Which one can we avoid? And so on and so forth. Does Azure has the capability of providing anomaly detection on the sensor data? And how can we do that? So answer is yeah, we have it. So will a hybrid Azure and on-premise solution require additional administrators, or they don't have the budget to hire new IT staff, and they would like to limit the maintenance work which is there. How quickly should we add new sensors to this solution? How quickly could we add new sensors into the solution which we are building now, right? The new one, which should be pretty scalable. Okay, we have new manufacturing devices coming in, and they wish to expand the number of sensors and so on and so forth. Now, a pretty common typical architecture is this one. Not for this customer. It will not satisfy all the requirements of this customer, but this is the starting point from where we can think, and then we can build something for them. Okay, so any typical architecture which goes into, you can say, IoT streams and somewhere maybe ML somewhere will be will be like this. So we have these IoT devices which are somewhere globally deployed. The IoT solutions in Azure have the capability of doing bulk provisioning. Like you don't have to manually go and configure. You can do that if you want, but how can we do it in a bulk in bulk as such? So maybe if let's say as soon as the customer enables the smartwatch, the that should get registered, and once it gets registered, it may start storing some data locally and streaming some data and so on and so forth. Okay, so cloud gateways, like when the data is coming from on-prem, then where is it hitting in the cloud? So this is the replacement of Kafka over here, cloud gateways. But if you can see, that's a single point of failure. So is it internally, regionally high available? That should be there. And how is going to be will how will it scale out, right? So those capabilities are anyways there, but that's something which we have to think about. Okay, now check this out. So everybody, all the customers, they whenever you go to them, they have couple of things. Uh, they have couple of set questions for us. Like one question which I get is that how much time will it take? So if we are doing any type of processing, if we are doing any type of job is running on the data, then how much time is it going to take for them to get the data in the dashboard? Now, honestly, when they say real time, they want it real time. Real time has many answers. Like real time with Spark can be in 3 to 4 seconds, 2 to 4 seconds. With as such Spark and stream processing. And I have also worked on few of the on-premises solutions uh, from Microsoft around 10 years back, where we used to, where at that point in time, real time was 8 hours. So literally, when the data was collected from the data centers, the dashboards used to update in 8 hours. And that's what we used to call 10 years back real time. That has changed today, right? So now, but the problem is, if you do something very fast, honestly, you cannot do it very accurately. There will be some sort of something will be missed. And if you try to take more time, then that you may be missing on the you can say that the time itself. Like if someone is waiting for you to do the fraud analytics, so they can swipe that they can pay for the restaurant's food bill, uh, then if you're taking more time, then they are just simply getting frustrated there, and the customer will not come back to us, right? So what we do is most we do the most logical thing. Okay, if we cannot do something, let's say if instead of doing something in just one flow, why don't we break it like one hot path? Let's create a lambda architecture, right? One hot path and one cold path. So here we have this is the hot path over there where directly the data is going from the cloud gateway into one stream processing solution, and it is throwing it out as such and updating the dashboard. So some reports will be visible very quickly in a very short amount of time as such. But they those counters, those numbers, those aggregated values may not be in depth. Now to do something in depth, we would like to store it. So that's over here. If you can see that one function app is running, doing some data transformation, maybe protocol conversion, or maybe adding some particular information based on some domain. Maybe going and reading something which is not in the screen right now, but let's say going and reading from some another location and just enriching the data and then putting it in some location like that. So many thoughts can be there. So we I typically used to use function app to do protocol conversions uh, to convert the fixed protocols FIX uh, in the uh, in the trading in the online trading systems. So those type of thoughts comes to mind whenever I see this over here. Okay, so we have little warm. So this is a very hot path. This is little. Oh, sorry, I clicked on it. Okay, so this is a warm part. This is a hot path, warm, and then that's the totally cold part. And there, uh, the ML solutions might be reading last 7, 10 days of data, or maybe month of data, or last 6 months of data, and then doing things with it, and so on and so forth. So this is a very high level architecture where the user management is done by Azure AD, and the business integration can be done by something like a logic app or maybe another solution also. And over here now, let me just see, is this requirement okay? Did you got what they are looking for? They're moving from on-premise to cloud. They don't have right now, the scalability is becoming a problem, and they would like us to help us in that, right? So now I will just take you back to the main architecture, and we will go through the individual components. I would like you to understand the full architecture first, and then I will show you the Azure portal. Once we understand the full architecture, I'll open the Azure portal, and then I'll just click on each and every component which is configured over there. Uh, and we will see the pros and cons and any other thought which comes to mind can be discussed upon. Okay, so This link is anyways in the meetup page itself. We'll definitely share it in the chat as well. Okay, so now notice. So my diagram is slightly big today. So it's I'll zoom out first maybe just to show it to you. Okay, so something like this is what is going to happen. This is what we are proposing to them, right? Something like this. Okay, so let's zoom in from the left hand side itself, and let me see if I can zoom in over there. Okay, so these are those five factory floors which we have, and they have 10,000 sensors over there in those five factory floors. So 50,000 sensors are there. And now the cloud gateway which we have is the Azure IoT Hub. Now Azure IoT Hub is based on Apache Kafka itself. And Apache Kafka is the best pub/sub model in the world. So Microsoft created the solution on top of it. But this is even better because it's a PaaS solution. So because of being platform as service solution, the amount of management which we need to do is very less. If you really work with Kafka, if you have logged in, maybe you have checked it out, you have deployed it or worked with it, you also may have worked with IoT Hub or Event Hub, then you already appreciate what these PaaS solutions are providing. Uh, and I have only few of the customers who are requesting access to the head nodes to run some job locally, which in past solutions are not possible, right? So for them, we still just say that okay, install Kafka with HD inside and take the run your jobs locally over there. But apart from that, a majority of the people which I'm coming across in, I have come across in last 5 years or 6 years have are adopting the PaaS solutions very comfortably as such because these solutions are reducing the overhead, lot of overhead tasks just to it's a huge frustration for the developers also. So if you develop something with Kafka versus with this, the efforts are also very less. Now, so what is this IoT Hub? It's a PaaS solution first of all, and and it is having partitions over there. So we can specify how many partitions do we want as such. So what is the purpose of IoT Hub? It will give us the capability of first ingestion of the data. So if somebody is publishing the data, the IoT Hub is the broker which will catch the data, or it's the broker basically. These are partitions. Data will go inside the partitions. If you don't specify the partitions, then data will be written in round robin manner. So uh, if you don't do that, okay. Now the importance of this will be in terms of device registration. My IoT devices from which exact device number the data is coming, how to register, how to securely connect to the device. That's also pretty important, which is taken care over here. Uh, and apart from that, like normal ingestion, definitely. And one of the very interesting thing with IoT Hub is that we have the capability of sending commands back. So sending commands back will be, let's say, if there is a conveyor belt in the factory floor and the conveyor belt is having a micro tier somewhere or maybe a major tier, or it's literally going to break apart, right? And your solution, you had a check somewhere or uh, that if the threshold goes beyond it, then it's maybe temperature goes beyond 1 point, then definitely go and stop or reduce the speed of the machinery which is running. So that we would like to execute right away. We don't want to call anyone. We don't want to show any alert. We definitely would like to show one alert also to the administrators, but we would also like to we would also like to have the capability of automating the response which goes back, which we can. So for example, here I have just put that. Let's say if something goes pretty bad over there, we can remotely send the stop command, start command as such. And this becomes even more significant when the devices are maybe are not in the factory itself, but maybe they are somewhere very remotely deployed. Then this capability of sending the commands and working with it is useful. So IoT Hub is basically bi-directional, right? So it is able to ingest data and it is able to throw the output back as well. Sorry, not the output back, commands back like that, something which the devices will be working with. Okay, now notice this. So behind the IoT Hub, we are proposing them to have the layer of to have the Azure functions which are serverless in nature. If the load increases, they will scale out. If the load decreases, then they will scale in. itself, and the solution will be able to handle what they are looking for, and will also be cost effective because the of the ability of literally be the compute is being allocated on demand only. So that is what we have over here behind the IoT Hub. So what this function is doing, this function in the when you will deploy this, maybe if you do that, right, I'll recommend you to do this. So when this function actually reads the data from the IoT Hub, what this function does is it adds few of the domain identifiers to the data. It adds some extra information to the data, enriching it, and then it writes it in the Cosmos database. So the Cosmos database is anyways, you can say, it's a semi-structured database. The schema is schema is not enforced on the write operation. Very fast to write at. So even if the amount of, you can say, load, if the number of functions go beyond one point, then Cosmos DB is also having the capability of auto scaling. It Cosmos database can also be serverless, can be a PaaS solution as well. So if you keep it as serverless, it's also gonna just scale in the same serverless manner between min and max limit. Min is always 400 RUs. Max is something which you are going to give. So it's gonna scale somewhere like that. Now Cosmos database is semi-structured, but this is the one which is having the capability of being row oriented and column oriented at the same point in time. Now, what that's pretty significant. Actually, I am pretty sure you all sort of uh, understand the importance of the being row oriented and column oriented. So OLTP databases are row oriented. They store data in the uh, data pages in row manner, like literally in row manner. And the OLAP systems or the analytical systems, they store data in the columns are stored in row manner like that. So there's a difference in how physically data is stored. So because of that physical difference of the data, we are able to meet the capability or the requirement of OLTP databases of getting few rows, one row or few rows as such, because data is stored in physically in that manner. And here, when you do analysis, you would like to read maybe hundreds of columns and billions of rows. So when you store those rows together, the columns are stored. It's basically all is column oriented solution. Parquet files. If you know Parquet files, that same concept is there inside the Cosmos DB. Once we enable the option, we enable the HTAP. Like HTAP is basically like a system which is both OLTP and OLAP. So hybrid transactional and analytical processing system. So we will enable it. Once we enable it, this is what's going to happen at the backend. So Cosmos database is going to break into two pieces. Imagine, right? So from the management's point of view, I don't have to manage two different containers there. Cosmos database is a semi-structured database. It is having containers in the document mode. So containers are equal to relational tables in relational databases. So if I have order container, let's say order table in SQL, then here it will be order container in Cosmos DB, just for you to remember. Okay, and this is where all the JSON documents are going right now. Now, a couple of things which you will come across is that there is no limit on number of partitions, but we have 20 GB of upper limit on one partition itself. So keep that in mind that you do partitioning properly. Now, apart from that, the auto sync is there, and the sync happens from the OLTP to OLAP within somewhere in two minutes as such, somewhere around in 2 minutes. So it is reducing that. It's first of all, it is eliminating the need of me to put any ETL job in middle to move my data from OLTP to OLAP. And OLTP are running my business and OLAP are doing analysis of my business. So now the ETL job is sort of nearly getting eliminated. And we have this auto sync which is going to move data around and will be very practical to work with. Okay, now, so we will be using it. So I'll show you how to do this and all that. But okay, so now a couple of important things. The request units are the resources. So request units which are allocated to the Cosmos DB in OLTP is different from in OLAP. So even if you start reading a lot from OLAP, it doesn't affect the OLTP part because RUs are different. Different resources are allocated. This customer right now would grow. Sorry, wide world importers, they basically have the need of they want to give different details over there. So they have literally mentioned that in one of the line that they would like to put a TTL, time to live, on the data in the OLTP to be 30 days. So after 30 days, data should automatically get removed from the hot database over here from this one. But that doesn't make any difference because we are not losing data, but we are anyways, it is going to be persisted. uh, and there is no upper limit on how many days are we going to persist inside Cosmos DB. They have said don't put any limit, so we are going to put 30 days limit here, and there is no limit. We will just say you will be there forever. Now, so the okay, so now notice this. So as soon as the data comes from the IoT Hub, the function app is able to add few of the identifiers in the data. Then we have another layer of function app over there. This function app will basically will be working on the change feed which is going to happen. So as soon as the data is coming, and they are reading the data from Cosmos database. And what is this data? This is about the sensor information. So the noise, vibration, uh, temperature, and all these information is coming from there. So what we will do is we will deploy one Kubernetes cluster, and in that Kubernetes cluster we are deploying uh, the ML models as such. And those ML models are also set to scale based on the your pod auto scaler, using the pod auto scalers over there. So the Kubernetes cluster is optional. Like in our example, right now, if the customer really hits the choke point that the number of API calls done to the model's location is limited because of some reason, then we can definitely have AKS over there, or anything to do with AKS, or any type of scalable solution, maybe something else as well, which is able to handle those many parallel API calls, and the models should be running there and the predictions are coming back. So I have just mentioned it like this. See? So some attributes are there, x1, x2, x3, and the predictions are coming back and models are running here. And how the model went there? The model went there, which we are going to go through, but the model went there through the ML Studio as such. We'll come to that in few minutes. So now the what we are proposing to them is that, okay, we are able to help you with the real time uh, the preventive maintenance or the predictive maintenance capability. We will create the custom model. We will deploy this in AKS as such. During POC, we can do this in ACI also. And once the function is able to find the predictions, those streams, everything is happening on streams as such right now. So those streams are further going into Event Hub, and then so what is Event Hub? Event Hub is the brother of IoT Hub, like that. It's also having it's also built on Kafka, but the Event Hub is one directional. Event Hub is not designed to for the IoT scenarios. IoT Hub is designed for IoT scenarios. So Event Hub is designed for all other scenarios, subtracting out the IoT scenarios as such. Any other event, continuous streams of events are coming, you put Event Hub over there. It's also a PaaS solution. Now, so the data which is coming from here, that basically is hitting the Event Hub, and we have one Stream Analytics service which is running behind it. So Stream Analytics service is another solution which is like a 24/7 running TSQL query over there, which can be further enhanced by JavaScript. So we are going to do that. We literally want to enhance by JavaScript. So the reason we have put it over here is uh, okay, so this basically is doing the prediction plus aggregation both of the outputs as such. So it is getting the preventive maintenance information from here. So when the machine is going to fail, that information already got scored by the ML model in this blue color cluster over here. Now that stream analytics is basically going to you do aggregation, but what we are doing here is we are using cognitive services which are running as functions inside the stream analytics. So cognitive services are pre-built AI. Now, and they already have the capability of finding anomalies for us. If you have vibrations with you, then we can find the forced vibrations out of other type of vibrations as such. These and the best thing is these solutions are ready-made. These are pre-built AI, so uh, we don't have to first develop them. Like, why can't we do that in Kubernetes? That's one of the question which should come to mind maybe. So why can't we do this with custom AI? So one thing is that if something is already available, then if 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 that is not performing well, or if there is another reason, like any cost dimension is there to your problem statement, if that is not there, then there is no point of reinventing the entire wheel again. Now, the cognitive services are world class. These are like SOTA models and they are state of art. So uh, we will be just able to use the uh, anomaly detection to find the spikes and the dips as such on various telemetry attributes. And we don't even have to maintain any DevOps lifecycle for it. Nothing like that needs to be maintained. It's a ready-made solution. Just need to run it over there. Okay, so we are going to use that along with Stream Analytics. So this guy is going to use that nonstop over here in this here green color dot over there, and then we are getting the outputs over there. Okay, now this Cosmos DB technically is the same one which I have on the left hand side also. I've just made it again over here because the arrows would have been very confusing going back to the other side, right? So this Cosmos DB is basically representing the same DB, but a different container there. So the container will change. And inside this container, we will have the scored output. So the information which was there in the original container was it had the raw telemetry data over here in Cosmos DB in this point in time. And now in the architecture over here, we basically have the scored telemetry data where the scoring has been done and aggregation has been done, and that is being stored over there. Okay, so uh, this I think I didn't fill up, but that's the web app. So the monolithic application which they have right now, that we are not going to take forward. We are going to break it into microservices. So we don't have a very you can say a very complicated structure, but we'll have 4 microservices which are running in uh, which will be running in the cloud, and this is where we are doing the which is this is where we are trying to uh, you can say provide. So we have CRUD operations. If I just explain that part, so there are CRUD operations. Now the when now the CQRS pattern or the command and query responsibility segregation, CQRS basically means that I should be able to segregate the reads from the other operations or some operations from other operations as such. So what we are doing over here is we are breaking the reads away as such. So in CRUD, the R is taken care by different microservice, and the rest 3 are taken care by different microservice. That much we have done in our example as such. So this is where we are trying to show them the capability of CQRS, which will be able to handle the operations with the databases better than not doing this. And we have one microservice which is basically going to get the metadata from the application side, and we have another container in the Cosmos DB which is called as metadata container, like that, where we are storing that information. And the AI part is basically being handled in the bottom of the page. So that's Spark. Sorry, that's Synapse itself. And as you already are aware of that, in Synapse we have Spark pool there, serverless Spark pool. So that red box is that. Jobs we are going to write. That's the ETL ELT pipeline. So even the cold analytics of the wide world importers uh, can be automated as well over there. So that's the dedicated SQL pool, which is the warehouse, which we are not using in this example, but you can uh, think it through if needed as such. Now, one thing which we would like to do is we are basically getting the data from all the different containers which we have in Synapse, so in Cosmos. So we are pulling data from here. We are pulling data from there as well. From the raw data, this is the score telemetry. That's the metadata, applications metadata. So the data is coming from all these different locations, and then we are this is where we are, and the way that it's being pulled is by with the help of Synapse Link, which is like a high speed fiber optic connection in their data centers. So we are getting the data from all these locations, and this is where we will be running the queries using Spark or using we can say the serverless SQL pool as well. on that. Now, once we do that, the main reason we are doing it is that we would like to see the capabilities of custom AI solutions. So custom AI solution from Microsoft can be created in the service called as Azure Machine Learning Service. It's not the only thing. You can also definitely use something like a DSVM also, but that's gonna be like a standalone machine. So it has its own limits as such. So now the Azure Machine Learning Service is that full platform, or it's the full package which which has the capability of providing the data science team or the AI team or the ML engineers CPU and GPU clusters where they can do the training. And but that's only one part. Apart from that, it also provides the capability of having putting your multiple environment versions, uh, having the dataset versions over there. By it provides the capability of abstracting the complexity of managing the connection configuration securely in the code. That is abstracted, that is taken care outside by registrations, and then we can just refer to the by the name of the registrations as such. So the data science team and the AI team will not, and the ML team will not be, you can say, they don't have to worry much about uh, the other complexities which are introduced in practical environments. It has data stores. We'll see it. Data store, data set, model registry. I can development environments are there, capability of registering the models. Designer is available, that drag and drop functionality. That's just the GPU cluster, and that's maybe me over there. Pretty happy working with that. Now the output of this is what is going in the Kubernetes cluster, where we are doing that is what was being used by the initial function app that was doing the predictions as such. So this is the solution which we are proposing to uh, wide world importers, and we are deploying it as well. So I'll just start showing you the individual bits and pieces, and let me just take the questions before I do that. So I'll just go through the chat once. I think you found the GitHub link, right? So, yeah, correct. Okay, some insights into the algorithms. We'll have a look at the algorithms. What is behind the IoT Hub? Behind the IoT function apps are there. These are consumers. So the publishers are on the left hand side, consumers are behind the IoT Hub. This is function app is basically a serverless solution. So it can be a Python code as well. It can be another .NET application code itself. It can be PowerShell script also. So it is something which is like which is literally serverless. Like it is the compute is allocated on demand, and it is scaling it based on real needs or real demand as resource requirement as such. And we are going to configure this that it can be triggered by it is like a IoT hub triggered, or it is like HTTP triggered solution. So that basically means like is how is the function app going to run, like when will it run. So either you can schedule it, you can manually run it, or you trigger it automatically. So automatically triggering the solution makes a lot of sense for us. So we have in all the locations where we are going to do anything with function app, we will be simply doing the triggered mechanisms there. Okay, so data ingestion tool is Azure Data Factory. Azure Data Factory is that is equal to that small box which you see in this diagram. So Azure Data Factory is exactly same as this is Synapse pipeline is exactly same as that this one, apart from slight UI change like this. So this is where that thing can be put in the diagram. Isn't function app costly as the execution cost is going to make the cost in terms of ML task? Is Let me read that question again. Isn't the function app costly as the execution cost is going to make the cost in the terms of ML task? Basically, this function app may not be very costly because first of all, they are it's not a continuous running job. They are coming up and they are getting you can say deprovisioned based on how much data is there in these partitions here. If let's say if we have more data coming in, let's say the wide world importers, they they add more factories, they add more machinery over there, then the then we also want something to be scalable as such behind the IoT Hub. IoT Hub itself is pretty scalable. We have auto inflation option over there. It automatically becomes bigger and like that. So this function app will also will be able to handle that. Now, will it be very expensive or not? Answer will be not really. Uh, they will be scaling out, scaling in on demand. Okay, so is the screen being shared right now? Okay, that's a pretty nice question. I hope it is shared. We okay, so let me just quickly scroll through a few of the questions. Okay, so okay, I'll do one thing. I'll start with the I'll start practically showing these things, right? Then then I'll take the rest of the questions. I think most of them will automatically get answered. Okay, so let's start from the from this ML part over here. The why are we starting from the ML part? We would like to start from here is uh, uh, from this point is because the 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 one of the primary execution which is going to happen, the primary function which is running over there, the primary logic which is running over there is the one which is going to get the data, which is going to do the prediction with the custom model deployed in AKS over there or ACI as such over there. So we would like to put that in place, and then we will see what is this Cosmos DB and so on and so forth. Then we'll see that layer and all those layers, and then we'll see the other components as well. So let's start from this green box, and let's quickly go through that. I'll take you to my Azure portal. Okay, so let me quickly find my Azure portal itself, and okay, so now when you will be deploying the scenario after the session, if when you will be deploying the scenario after the session, you have to create you have to there is a template you have to run, and that template basically will do some baseline infrastructure deployment for us or some vanilla infrastructure deployment for us. So around 25 resources will get deployed automatically by the template. So you don't have to worry about the things which are, you can say, not really important from our discussions point of view. The infrastructure resources will get created. So we will be having application insights. We'll have key vaults for securing the keys. A few storage accounts will be there, which are coming up, and Spark pools will be there. The app service plans are there, where the web app will run, the last web app, and we'll have the Cosmos DB. This is the way where all the containers are available. We have Postgres also. Few of the microservices are already. I deployed all the microservices as such, so I can walk you through all of them. And container registry is there. Dedicated SQL pool is not being used, but you definitely can also uh, go through it. That's the event hub, and we will have function app. And this particular function app will have the individual functions over there. The two functions which were in the diagram will be there in this one. And that's the IoT hub. We'll have this key vault is I think deployed. And let me see what was the okay. That's the same one. I realigned the sequence there. Okay, so that's what we are looking for. That one, and these are just NIC cards and so on and so forth. And this is another important service, stream analytics service, where the aggregation is going to happen, and the cognitive service jobs are going to run over there. So this is we'll go into that also. And this is the main Synapse workspace where we will do a lot of configurations. That's just my VM. Yeah. So let me zoom out so I can also look at the screen, and let me find the ML service first. So okay, so if it would like to get launched or not. Okay, so we are over here right now. right? So what are the pointers which we are should be aware of? This solution is basically having the capability of connecting to various data stores in Azure. Data stores are literally, uh, you can say, data stores are literally the locations where your real data is kept, like ADLS, storage account, Postgres, MySQL. So your data science team will be able to get the data from these locations. What happens if some of the data store of Microsoft is not there? Then we have other capabilities by which we can also get the data. So that thing is somewhere here. So if I can just zoom in slightly more for you. So notice this. Okay, so we have these data stores. Now we have, so if I click on few of them and just show it to you. So, okay, check this out. So blob storage, file shares, the deprecated one, ADLS Gen 2, SQL, Postgres, MySQL, like that, can be connected. And then you can specify how are they connecting, which to which storage account are they connecting, and what's the container name, or what is that equivalent HDFS share which is there in the ADLS. You can specify that. Get your keys, put it here, use the key mechanism, or you can use the SAS token, or use the service principal for other options as such. So what I have done is I have uh, created one of them myself, which and that one will be the first one over here. So I basically have registered one data store where my data is available. We have historical data with us, and that historical data is having the device states, like in which device state did the output. Okay, so what was the device state and whether the device finally failed or not, and when it and what was the timeline between that, like when did it finally failed as such. So that information we have, we want to learn the patterns from it. So the data is available in this ADLS over here, and we are just registering that ADLS with a name, a modern app store over here. Now, once you do that, the second thing is we have compute clusters. These are the development environments. These are the training environments where the training happens. This is where you can have the Kubernetes cluster. So this is basically that purple box over there, this one, like that. So over there, and attached compute is like data bricks, or anything which is outside this particular workspace where you would like to train your model. Now, so they are minimum required, like these compute locations and so on and so forth. Okay, and then I will just take you to my notebooks. Other things are also there, AutoML and so on and so forth. If you have any specific question, just put in the chat window. I'll take your questions on the way. Okay, so I have this notebook with me, and let me just see. Okay, so okay, now okay, so how do you work with the Azure machine learning services, right? So there are some boilerplate code. We'll cover the boilerplate part of it, and which is going to be there in all of your solutions, like logging. How do you enable the logging? How do you connect with the workspace? How do you connect with the experiment, and so on and so forth. So those are the type of things which are there in all the experiments itself. There is nothing. It's not that. It's the baseline, like it's the minimum requirement, and you have to put it over there. Now, if I take you through those points first, uh, notice this. So we are getting the data from the data store. That's the data store which we have specified, and that at the backend is a data lake as such. So we don't have to handle it right now in this particular notebook. Now we are getting the data. We have this historical maintenance record CSV over there, which we are getting from there. And then this is the where we are doing the normal ML split. We are breaking the data into X train, X test, Y train, Y test, four pieces as such. With the X train and the Y train, you are training the models. With the X test and the Y test, we are testing the models as such. Now we basically, so okay, so notice this, these two steps over here, these type of steps will be there in all of your Azure machine learning specific experiments. So what the first one does is it basically connects to the experiment which is there over here. So experiment is like that umbrella where anything which you do will be logged and all the information will be available inside uh, that umbrella over there. So if I click on this, this is basically going to be having some information over there about let's say, some information about my experiment right now. So like this. So everything is getting logged in this location. So we have to connect to it. If we don't specify it, there is no way to tell it like where do you have to do it, like where do you have to underneath which experiment, underneath which run are we running the job right now. So those are a couple of things from the executions point of view. Logging is pretty important. When we start the logging, then you may want to log the accuracy which was let's say the final accuracy of your model. You would like to log any particular distribution of the model. You ran a query and you would like that information to be saved for you. So you enable the logging, and in your run IDs you will find the more details. If I click on any one of them, you see we have some accuracy here, 94 accuracy. Some matrices are here, and few more logs will also be there. The raw logs will also be there here. Literally, model is lying there right now. So I would like all of this information to be logged for me. So that will start happening from this point onwards. This is a simple, we have a descent tree classifier over here. So classification is going to happen whether this device is going to fail or not. Now, the okay, so this is, if you can see this, this is specific to Azure machine learning. Rest is just machine learning. This is specific to the SDK itself, like run.log. So this run.log is going to just log the value of accuracy in the underneath the experiment. So if I take you back, that value actually came from this line, this value over there. So it's gonna take it. Now, why is this so important? When I do a remote submit, like right now I'm running in this in development environment, but if I do a remote submit to another remote uh, cluster, then I don't have the visibility into that cluster in that point in time. I'm not able to look at what is going to happen over there. So logs will be a very good source of troubleshooting which we can do uh, over there. Now the okay, so output model, we are saving the output model and so on and so forth. Okay, this basically means that my run has completed. Run complete means that this is specific to Azure ML SDK. So if I just show you that, so if you just go one page back, so you will notice that we are having, so these are the runs for here, like runs have happened. So the run will complete when the run complete will execute. So if we don't do it, then the run will keep on, will not execute as such. That complete part will not happen, and then some timeout will happen in future like that. Okay, now so what we have done is basically we have trained this model which is going to be which has learned on the historical maintenance record which we have, and that particular model is what we have saved in the model registry. So if I take you back to my Azure Machine Learning Studio, and in the model registry we have this over here. If you run it multiple times, you get multiple versions, which is also pretty practical for us because uh, if for example, if I may have done different hyperparameter tuning, I may have used different algorithms as well. I may, or maybe practically, if I would have used different algorithm, I would have should have made another experiment. But imagine there is something which is uh, you can say that okay, on different day you try different things and you would like to have those equivalent models versioned for you. The versions are such, and the important thing is the tags and the description, the property to track it back on a later date. How can you find it? What did I do on that particular day? Okay. So once we have done this, this is what we are going to use. There are two ways, or there are many ways actually in which we can do the deployments. One will be definitely from the Python itself, and they have these type of things available. So you can click on the deploy option. You can deploy as a web service, and this is what we will be going ahead with. Now, when you do this, you basically can just click on the on what are you looking for. Like when you deploy this, do you want to deploy this in AKS or do you want to deploy this in ACI? Now, practically, the AKS deployment just like that will not be very appropriate as such, or we should not be doing this exactly just like that, like click and deploy, because that is not going to be very cost effective uh, as such. So these are ACIs are the individual, you can say so AKS is the orchestrator. These ACIs are simple locations where your containers can run. So those ACI locations can also be seen. So this is more, you can say, that's more production oriented, and this is, you can say, more like test oriented. So if I just give a name right now, so okay, so I just want to show you for one thing on the next page. So I have to select something over there. Okay, so we would like to go to the next page. Let me see if I can show. Yeah, okay. Now you see these script files and the dependency files. So now the capability of AML Studio, which we would like to explain to the wide world importers, will be that it is providing the abstraction from the Docker, the containerization process for the data science team. So what this script file does is this script file is a score file. It is supposed to be there in the final Docker container, which is running in production. And what it does is when the data comes over the API call, this is the one basically which does the initialization. It loads the model in RAM. It picks up the data from that API call, puts it in an array, and basically does the model dot predict and throws the output back. And if you would like to do any logging, or if you would like to do any beautification of the output, this is where you write it in this script file. It's a you can like that. So we have to specify that, but we don't have to do the containerization ourselves. Secondly, if I just specify the dependency files over here, what I'm looking for. Uh, so if I can just click on some of the curated environments which we might be having. Oh, no. So I think it should be somewhere. I'll show you in a different location. So basically you can specify the CPUs and how much RAM is going to be there and so on and so forth. Okay, so what this file is basically going to do is, if you're aware of the Docker file concept in Docker, this is exactly what that does, like this. So my your data scientist, or basically you guys, are going to simply give those two information. So the environment file with all the dependencies, and the score file, which is going to have the init and the run functions over there. This and the model. Three things are required. Rest is taken care by the platform. So the platform is going to create one Docker image. It is going to put all of them. So based on the environment file, the dependencies will be installed over there, like this. Model is your model, and the script file will be, or this entry file or the score file basically is the one which is going to do the model.predict later on as such. So the data science team or the AI team, ML team doing the modeling right now are abstracted from the way it is done in production, or the way we would like to decouple the solution from the underlying environment by using Docker. So they don't have to worry about that. It's just part of the, if they specify the files properly, it's done, right? Taken care by the SDK itself. So now that's what we are going to do. So I have already uploaded the file, and when you will do the example, you will also find the files available which you will be using. So once the deployment happens, basically, if I can take you one step back, so that purple color AKS cluster is the okay. So this is ACI right now. This one over here. So this is where that ML model, which is custom trained, is deployed. So and it is running over here like this. And this is the one to which that function app will be doing the API calls to. And the endpoint is exposed and listed over here in endpoint section. So we can have a list of the endpoints as well, like how many are active right now and so on and so forth. So this is the endpoint of the custom model. And this is what my purple color diagram over here is representing in this location, like this. And if we would have selected the other option, AKS, then it would have made the full cluster, and my single model would have been running over there pretty happily. And you can definitely do that. Okay, now let's have a look at the Cosmos DB part. I'll just take few questions. I can see a lot of questions are there in the chat. So I'll just take maybe five questions, and we'll try to reduce the number of the questions which are there. I would like to understand prompt what prompted the use of Event Hub in the flow. Anything stopping to input the stream directly to Stream Analytics? Okay, okay, okay. I'll explain that. Okay, so do we have a function app for each of this type of sensors? No, we only have two function apps. Only two logics are there. Sensors can be different. We are handling the different data in different partitions over here by different device IDs as such here and there, and also in the Cosmos DB. So different device data is going in different location, but we haven't right now thought much about if there is a need of different function apps processing different type of device data. Definitely you can do it, but the structure will still remain same. Okay, so we are not using ETL process because the response time will be in seconds. ETL process will be you can say will take hours to maybe days, or you can say weeks. It's a ETL is basically scheduled as such, and this is real time streaming which we are right now talking about. Synapse and ADF pipelines are not exactly same. Yeah, they are not exactly same. There are some slightly small changes over there, but they are more or less similar. Okay, so hot and cold path in the diagram. Okay, so hot and cold path. Okay, I have to specify that hot and cold path. Hot path is pretty specific right now. See, it's pretty obvious. So data is coming from here. It goes like that, get processed, and the output is going somewhere in this location over here. And then some microservices further modifies the output location. For the cold analytics, I don't have anything in the diagram right now. But if I really have to put it somewhere, then imagine that this is the, you can say, a better example for it. I have it over here. So if you can see that, let's say this is where you have from here you are reading the 7 days of data, and this is where from where you're doing the real time data. So the function app is actually getting data from there, and for the ML process we are reading from the warehouse part of it. So this is your cold analytics, the right side of it, the 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 mirrored Cosmos DB which you have, and the bottom arrows are representing the colder analytics right now, and that top part is the one which where the hot path is happening. Okay, so let's go and have a look at the Cosmos DB a little more. So we would like to have a look at that. Okay, so let's find the Azure subscription first, and let's take you to the Cosmos DB. Now, Cosmos database is okay. So this is my Cosmos database, and over here, Data Explorer is where we have all the that's equal to SSMS, similar to that, right? Not exactly SSMS. SSMS is having a lot of functionalities. This is just an editor over here, but from here you can replicate data globally. So if I want, if the factory floors, as the factory floors are globally distributed, so what I can do is I can select these locations over here, and now I can also specify that do I want multi-master, or do I want one master and other will be read copies. In multi-master, all will be read write copies. So from this tab, from this nice looking UI, you cannot do it. Earlier, if you remember, we used to open that gray color SQL box to make the always on clusters. That time is gone. Now we do it like this, like we click and we save it over there. Now, something which is important is we have to go to the features, and in the features, we have to enable the Synapse Link. Synapse Link is that high-speed connection between the Cosmos database and the backend Synapse clusters as such, Synapse workspace, or where the Spark cluster is there. We would like them to be talking on a very low latency network. So that is enabled from here. We go and we enable this. Now, once we enable that, we are going back to the Data Explorer, And this is where I will have my, you can say, I have my containers and my databases. So databases have containers inside that. Database is equal to database in relational database also. The containers are equal to tables. So if you have, so if I just expand some of the things, so I have this container called as sensor. Sorry, I have this. These are the containers over here. Scored telemetry, telemetry over here. Telemetry. This is the metadata. Some other logics are there. So this is the one where raw data is coming in right now in the bottom one. And after the scoring uh, and after the aggregation by the stream analytics, the output is going here in this one. This is the one which is this one over there, which is having application oriented data or metadata or any other metadata is there in this one. So we have created these multiple containers over here, and the Cosmos remains same, but the containers can be are different over here. Okay. Something which I just want to show you is, let's click on any one of them maybe. So how do you see the data over here? If I just quickly can click back and open it, and would like to just see one particular file there, one particular item. So we call them items or documents in Cosmos database. It's a right now it's document mode. So machine ID 12345, temperature anomaly was detected on top of it, and this temperature anomaly was done by cognitive service anomaly detection. I will walk you through that. The entity type is machine telemetry right now. The entity ID is there. The event data is also event data factory, first factory, some machine information. Temperature was something, something, something. Pressure, humidity, uh, and maintenance recommendations were not there. So the custom model said that don't do anything. It's totally working fine. But temperature anomaly was detected. So we have to do something about that. Okay, so spikes, or is there any anomaly or not? And these are the IDs which are added by the Cosmos DB itself. So these are not coming from the data itself. These E tags and all are important, but not right now. So this is the scored output. And if I just take you to the diagram back again, and let's trace it step by step. Okay, so let me show you a couple of disjoint pieces over here. Let me just show you this part over here first, so we can just complete the ML part. So Stream Analytics is running that query in the system itself, and it is going to find the spikes over there. So let's have a look at that, and let's go to the Stream Analytics service, which is going to be doing it over here. Now, if I just find my service, okay, this one. Now, it's a pretty straightforward service. It has a couple of things which you have to work with: input, output, functions, and the query. Four main things as such. And then maybe what's the retry pattern? Like if something fails, then what should happen? Those things can also be configured over here, like error policies. If error happens, then what happens? Let's say it tried to write in the output location, but output location is not available, didn't respond it back, and so on and so forth. Then what is the error policy? Pretty important. You have to put it over there. Now input is like the input stream. From where is my stream coming in right now? Stream can come in from IoT Hub, Event Hub, and Blob Storage. So this is the answer for the question which was saying. The question was that, can I directly connect the functions to Stream Analytics? No, not yet. Maybe in future they will do something with it. But no, not yet. So I can have these streams coming from Event Hub, IoT Hub, and or we can read as a streaming input from any static location like ADLS or the blob storage. These are reference stream. When you want to enrich the data, you can use these. So we have configured one of the input stream, and this is basically the event hub which we have uh, just before the stream analytics. in the diagram over there, this blue guy, and this green service is what we are looking at right now. So here what we have done is basically basic configuration, nothing very specific. We have just specified the event hub name, the consumer group. Consumer group is basically so what is a consumer group? Right? That's pretty important as such. So uh, these are my consumers. Okay, not let me go back to the main diagram over here. Okay, so these are my consumers right now, like this, right? Of the data which is coming from or these are consuming the data from the IoT hub. Now we can group them. Why do we group them? Inside the same consumer, we have individual consumers as such. Like the limits are in one consumer group, you can have 5 consumers as such. So the reason we have the configuration in this manner is that if something goes wrong, let's say one of the function app didn't perform, went down, whatever happened, the others can just pick up the data and will be able to process that. So consumer groups are defined. You can have multiple consumer groups. Someone can correct me. I think that upper limit is 20. 20 consumer groups can be there. So you can have 20 different type of backend consumers who are doing their own logic on the data. So that is the answer for the question where we were thinking of that. Can we have different functions for doing to working on different device as such, running different logic? Totally possible. Okay, now if I just take you back to the uh, to this authentication mode and so on and so forth, what type of data is coming in JSON format. So Event Hub is throwing JSON right now, and function basically means that what is the logic which I'm running here. So if it's grayed out, but if I click on it, there are 4 options there. Uh, 2 of them are JavaScript oriented functions. I have to write them. 2 are ML oriented solutions which are already available. So what we have done is we are running one query right now, which is going to do which is basically running one inbuilt cognitive service logic over there. So if you can notice this, so we are just getting the raw data. Select the machine ID, temperature anomaly, machine anomaly, entity ID, event data, and do you can say anomaly detection, run the anomaly detection step on top of it. So event type, entity ID. If the temperature is between some particular range, find the when the spikes are there, find the anomaly over there, uh, and then we can have you can have multiple windowing functions over here as well. Like output of one can go in the other one can go in the third one, and so on and so forth. So the main thing which we are doing is we are finding the spikes as such or the dips. If there is any spike and dip has happened, is it an anomaly or not? Is it maybe because somebody turned off the device, or maybe somebody has increased the speed of the conveyor belt, so it's moving very fast, so its temperature has gone up, or is it something which has happened because of some anomaly over there, maybe something maybe creating more friction than required. So it's inbuilt. There is no need for us to invest our time into creating this in the custom solution in the machine learning studio. So those type of capabilities are available as part of cognitive services. We can fit them in the streaming logics or use them independently also, if not over here. So this is that arrow, which basically is using uh, the AI pre-built AI solutions over there. And the output of this is the Cosmos database, which is the scored output, which you can see from here as well. That the output location will be somewhere specific over here. So if you click on this, you can find around 15 to 20 output locations over there where you can write your streams. So we are writing it back into Cosmos database in the scored telemetry section over there. Okay, I'll take few questions on the way. From Synapse, can I access ML Studio's default dataset? Uh, from Synapse, can I access the ML Studio's default datasets? If I install the SDK over there, then yeah, Azure ML's SDK can be used uh, as such. Now, when you say default datasets, these are the preloaded ones. The ones like the toy data set where we do the linear regression, the automobile pricing data set. That's one of the toy data set which is already preloaded. I think so. It should it should not have any technical issue in being pulled from there. We can check it out. Not really sure about the preloaded one. If anything about from preloaded one, yeah, we can do it. Yeah, everything is in GitHub. The links are there. Scripts will not be available as output of AML. I didn't got the question, Balaji. You can ask it again, right? Okay. Okay. So last question is, where is the event sourcing used in the architecture, and which data store we use it to store the events? How events sync? Okay. Now check this out. This is where we are doing the event sourcing. So, for example, if you notice over here, the function. So doing the instead of doing instead of only maintaining the final state of data, event sourcing pattern will ensure that the events are immutable, and we have the history of the changes also on the way. So we have implemented the event sourcing pattern once over here. So we where the function is running on the change feed of the Cosmos DB, and then the output is further, you can say, if I can just take it further, over there is not stored at the same location, but there are further logics on top of it, and it is being stored. The events are going in another Cosmos DB location, which is another store which we are using right now. So the store which we are using right now, one of the store which we are using is Cosmos DB, the where we are maintaining the changes and the history as such. So this exec, that step is one of the change feeding where we have implemented that. Okay, the Python script file. No, that file we have to know. Like for example, let's say you have used 10 algorithms to, sorry, you have used 10 libraries during your model development. Then you know it, which 10 were used. So you have to define it in the environment file carefully. And then you just have to tell Microsoft, so you just have to tell Azure ML SDK that, okay, this is my environment file. Please use this later on. One thing which is very good for us is that we are able to store you can say the environment files also. If I take you over here, you see the environments. So you can keep them ready, and you can just select them during the submit task itself. So here I can see the curated environments are there. These are provided by the platform. This is where custom is there. I don't think if I have any custom with me right now, but I could have put those there. So if I click on one of them, just to show you that what is going on inside it. So this is the PyTorch with CUDA as such. So this is the equivalent of, so this is that Docker file equivalence of that. So it is going to pull the base images. It's going to install Python 3.6 pip, PyTorch, Torch Vision, Auto, Torch Audio, and so on and so forth on that. And if you keep it over there, you can use it later on in a modular manner in your pipelines. Okay. Okay, so what I'll do is I'll take you to the Synapse once, and we would like to see a couple of important things from Synapse, which are important from the point of view of how are we doing the cold analytics over there? Like, how is this Synapse link helping us out, uh, and so on and so forth. So let's have a look at that as well. So now I'm just gonna close this. Apart from that, we don't have much options to do over here, which is a very good thing that we don't have to focus on things which are not very productive for us. So you have to work with the input, the functions, the query will be there. You can have as long as a query you want, and the outputs over there, and few important things in the bottom of the in the configuration tab over here about the error policies, and how the ordering of the events may happen. And if I just take you to my Synapse, Okay, so this is going to load. There's a question in the chat saying, what is the difference between the prediction? Okay, the difference, Aditya, in the data which we have, which this function is doing is, uh, this one over here is that if x1, x2, x3, x4 comes from the Cosmos DB, then this goes and get the prediction of on top of it. That prediction is for preventive maintenance, or is to predict when this device will fail as such, and based on that we can do the maintenance of the device. So that scoring is what we are doing in this one step with the help of custom ML model there, which is trained on the historical maintenance history, and then that data is what is further going in the stream analytics, and where we are further uh, doing more anomaly detection on top of it, and then final aggregated data is going in the Cosmos DB after that. So in every single stage, we have the capability of maintaining the different uh, the events, the transformations which are happening. We are not overwriting the old value. We are leveraging the capability of the event sourcing as such, to create those immutable events from one into another one, and we have the history as well, which can be further traced, stored, and so on and so forth. So let's go back and have a look at the Synapse. So that's my workspace, and this is where we have the pipelines. This is that ADF equivalent pipeline, and this is, uh, if you have worked with it, you already are aware of it. So that's how it looks and feels like. So I can create the ETL and the ELT jobs over here. Minor cosmetic difference might be there from ADF, but it's more or less similar. Now, but that is not going to be real time. So this can is useful for me whenever we are doing the cold path analytics as such. This will be useful for us to orchestrate the solution in that. Now, something else which is very interesting and important is the data flows over here. So data flow is a code-free Spark transformation. When this transformation runs at the backend, it runs on a Spark cluster only, but it is totally, I can say, code-free, which you may be able to see what we are doing. We did few sessions on the uh, on this particular concept, where we used the data flow to do uh, the ETL job creation on top of it. Okay, now notice this. So that's the data section. Here we will have all the warehouses listed. So that's one of my warehouse. And the one which I'm looking for right now, I was looking for the my notebook. So which should be saved hopefully here. Okay, that's the one. Okay, so check this out. Now the Spark cluster is having by default 15 minutes of termination as such. So if things are not running, if things are idle, then after 15 minutes, it just automatically terminates. You can change that value. And the Spark cluster will only come up when we start with the execution. So it is coming up right now, and they just have a context, and minimum is 3 nodes will be there, one worker, two worker, one master as such. So the Spark is coming up. That's the serverless Spark. So it will come up, execute my job, and will, once it becomes idle, it will terminate after that. Okay, so the you can use multiple programming languages as well. So we are using Scala, but you can use PySpark as well, uh, .NET Spark and Spark SQL in Synapse. So this is what we are recommended to wide world importers for their ML, or you can say for their big data, or for their Spark requirement, or for their compute requirement, for their distributed compute requirement as such. Now, the most important thing over here is just this single line, cosmos.olap, over there. Now, let's find the equivalent of it. Um, okay, so this is the read, and let's see what was, yeah. So let me see if we are also doing some write operations in this one or not to the same OLAP. Okay, So OLAP. Okay, I'll just so how is that? What is that? What's the meaning of it? So see, cosmos.olap use this linked service. That's where you have to read from, right? That's the name of the container inside the Cosmos database right now. So uh, now by writing it in this particular cosmos.olap, what we mean is that the data should be coming from the column oriented section of the Cosmos DB, not from the row oriented one. If we want to read from the row oriented one, we have to specify cosmos.oltp like this, and same container, and just specify the connection configuration. And over here we have to specify the cosmos.ola like this, and same container. So container doesn't get changed. We don't have to maintain two different containers now, but we are able to read from either from the row oriented transactional part of Cosmos DB or the column oriented analytical part of Cosmos DB by specifying that one single, you can say, by specifying with that cosmos.olap or OLTP like this. So which is pretty useful for us when we create hybrid transactional and analytical systems. So there is a system called as HTAP. If I just make a box over here, this is HTAP right now. This with that is HTAP. So where we are having transactional and analytical processing also by using Synapse, Synapse Link and Cosmos DB. So okay, so these systems are the hybrid between OLAP and OLTPs right now. So we were able to enable that by enabling the Synapse Link over there. Now, if I just take you back to the notebook and let's have a look at this, right? Let's just have a look at this. So we are getting the spark.read read from here. Use the linked service. I'm pretty sure you are aware of it. If not, then this is a linked service over here. If you click on this, basically we are able to specify the connection configuration, like from where do I have to read? What's the key to connect to Cosmos DB? Should I use service principal there? Should I use MSI over there? So how do I connect to it? And from where do I want to read like that? Okay, apart from this, we are doing some few selections on top of it. And then this is one of the, you can see that factory ID, electricity utilization. We understand the machine ID, the pressure, temperature, and the time that particular event was generated. So this will be very useful for us during the anomaly detection in the pressure itself. Now, uh, okay, so yeah, table already exists. I already have the table, so this will throw the error next time because obviously table already exists. So that's great. Now, if I just run this again, because the table already exists, then just execute. Okay, so we just want to see that the that scored telemetry which we have inside in the Cosmos DB, we are reading from there. Now, one of the reason we want like to read from there is so we can maybe we can have the retraining of the model done with the previous, or we can check out whether the previous analytics which was done on top of it and the scored output which were there, uh, do we can we use that data for let's say the next training cycle which is going to happen, because you will need more data to keep the models more relevant. Okay, so anomaly already exists in the database. Okay, so no issues. Then one more thing I would like to show you is that if I go to Power BI, so I have the Power BI somewhere open with me on my secondary page. So check this out. So what we have done is I have created one user in my Active Directory, and that user is basically named as Power BI user. That's the name we have given to that user. This one over here. Now, apart from this, I went to the Power BI trial license and I logged in with that user and I got the 60 days trial, right? So that 60 days trial is now applicable on that user account. Okay, then I have logged in into this into Power BI online over there, and I was able to log in and things were, you can say, but looking fine. Then what we can do is this report. I'm pretty. You can say you will say that okay. I didn't had much time to make the report. It was supposed to be more beautiful than that, which I will leave that part onto you to do that. But the time which I had, I just did it a little quickly. So if I just want to show you a couple of interesting things over here is that what I can do is I can simply come to Synapse once my dashboarding. If I have the license, I can simply come back to Synapse. I can click on this visualize option over here, uh, or I can click on the data and I can just wait for the for that to load. I was hoping for this to load here as well. 1 second. Okay, yeah, sorry. Develop first. Now we have this. So once you integrate with Power BI, and how to do that? Let me show that Power BI integration first, because that is something which few of you are interested into. So manage, then click on linked services, and then new, and do the Power BI integration from the pop-up over there. And let me see if I can get the Power BI pop-up again or not. Okay, so it will ask me to authenticate because I have the license. It is able to get my workspace. If I don't have the license, this step will not go ahead from this point onwards. So if you are going to try what I have just shown you, then you can also just create one directory user. That directory user will be equal to organizational user, and on that organizational user, you will be able to redeem the Power BI trial for 60 days, and you can simply do your experimentation for 60 days with that. So once this is done, and if we just go back, we will be able to integrate that inside Synapse over here, and we can manage or create the reports, and you can say uh, everything inside the same Synapse location itself. We do not have to go into heterogeneous portals or pages or do something here, do something there. Synapse is that single analytical one-stop solution for wide world importer, and where reporting is also embedded. Okay, now something which is pretty interesting. What else we would like them to do is once they have the license, they will also be able to uh, export this. Basically, if I click on the website option over here, it will show me the embedding, the link to embed my Power BI report, and we will be doing that. The instructions are available for that. And once this report was not actually looking that nice, but this is what will embed finally in the web app over here. So wide world importers wanted the factory manager to be having the dashboard where they can see the real-time updates, and we have the capability to provide them exactly what they need, but in cloud, in a better scalable, cost-effective, uh, and pay-as-you-go model rather than buying the servers ahead of time and with the help of capex architecture there. So avoiding all of those things and keeping everything as modern as possible, serverless, scalable solutions, and this is what we are going to present, or this is what we have for wide world importers. So I'll just go back to the objections and the questions which they had. We'll just have a look at that. Were we able to answer all those questions, or is there something which is still left for us to cover from their case studies point of view? And once we have done that, I'll just take your questions, and I think that will be what I have for the day. Okay, so let's go back to the. Okay, now uh, we want to centralize the factory sensor data into cloud. Done. PaaS. We have the PaaS solution. I didn't told you, but we also have a SaaS solution also. So there is a concept called as IoT Central, which is a software as a service built on top of IoT Hub, which is even uh, you can say even far more amazing. It has nice dashboarding and capabilities of very easily managing your different factory floors. Maybe you can create different dashboards, different sections over there, and then different dashboards. Grouping of the devices can be done, and then on the grouping of the devices, we can have some non-ML type of logic also, just if the threshold goes beyond this, send the stop command back. We don't need any analysis for that. If the threshold goes beyond some point, if the temperature goes beyond one point, just simply go back and stop the process. Those type of logics can be implemented directly uh, there. But if I would like to understand that what is the forced vibration, to differentiate between the forced vibration and the natural and the free vibration, then I really need ML to be there. Otherwise, I cannot do that. So yeah, we have all the capabilities, and we would like to replace Kafka. We can replace Kafka with IoT Hub, and we can replace. So we can literally replace Kafka with IoT Hub, and if they are looking for, let's say, we also have suggested Event Hub. An Event Hub was suggested for that low latency event. To complete the event flow which we had to put it over there. So we were able to get the predictions, custom predictions. Then we were able to aggregate the outputs in a smaller job in Stream Analytics, doing running the pre-built AI solutions on top of it, which are called as cognitive services. So this is over there. And the consumer group, yeah, we were able to do that. There is one consumer group available. So factories are available globally. Our solutions are also are available globally. Cosmos database literally is a distributed database, and we will be able to have it in. We will be able to scale it in multiple locations as such. Okay, so storing of the data in the cloud, we would like to integrate ML. We were able to integrate ML. We can train our models on inside machine learning service itself. We can even train the model inside Synapse and just register inside the machine learning service itself. And we can containerize it by providing the scripts, and we were able to deploy it directly from that location also. And in in your practical scenarios, you will not deploy directly from there. You will have a DevOps pipeline, CI/CD pipeline, or MLOps pipeline created on top of it, which is also totally possible, but we didn't do that today. Okay, so classic web server is, yeah, not there anymore. So can we process large amount of sensor data at each factory with a cloud service? And will a cloud service be able to keep up with our data requirement? Yeah, sure. Now, one thing which we can also suggest to them, which is not here discussed, is we have solutions which can be deployed locally in the factory itself. Like instead of streaming everything to the cloud and then doing the analysis, why don't you do some sort of processing locally, and maybe if required, send some output to the cloud, and not choke your network also, uh, and do the processing locally in the factory floor itself. So we have edge scenario solutions available, but we haven't discussed anything over there. Okay, so capabilities of performing anomaly detection. Yes, we will. Can we have this hybrid Azure and on-premise solutions? Yeah, done. How quickly we will be able to add solutions, and how will quickly we'll be able to add sensors to this solution. We have the capability of doing bulk provisioning of devices. So pretty fast, and just by provisioning, our responsibility is not done. So we have the solution in place right now, which is scalable as well. Okay, so let's go through your questions. That's what I had for the session today. And the next thing which you have to do is the links. If you have not bookmarked the links yet, I will put it again in the chat. But if you bookmark the links, you can deploy the end-to-end solution. I'll just put the links one more time. And let me read the questions. And if you would like to unmute and maybe speak also, that's also fine. Okay, so there are a lot of questions. I'll just scroll back, and I'll try to find the last one which we have seen. Okay, so um, okay, so the Python script file that you mentioned to be available in the Docker container along with the environment dependency file. Will script file be part of the output? No, we have to specify that because we can customize that. Minimum there will be two functions there, init and run, to initialize the model and to run the model. Where in run we do model.predict. But let's say you want to do pre-processing or you want to normalize the data which is coming during the API call or is coming in real time, then you can also run those functions inside. We can have that logic inside the run function also. We can add more functions also there. So, but minimum two functions are there, init and run. We really have to specify how will they be looking like. So the sorry, I lost the sequence of the questions. I will just trace that question back again. Okay, I think I did answer that question, Aditya. So I'll just skip that. Okay, how to partition Cosmos DB into OLTP and OLAP? Yeah, pretty straightforward. Notice this. So if I just show you that part, how do you partition that? Like it's not we won't call it partition. We want to enable the HTAP concept. So or we have to enable the analytical store. So you can do it by just one click now. So I can show you um, like this. See, if I enable this, if I keep it disabled, it's only going to have the OLTP part, meaning only the left hand side of my diagram right now, only this one. That auto sync to the OLAP is not going to happen, right? For that particular container, it's on container basis right now, right? So if I enable this, then with that same container, now it's going to store the row oriented data, or you can say it will have now two it will have OLTP different from OLAP for the same container. And this is row oriented, that is column oriented. So physically data will be kept in a different manner. So that is how you enable it from this radio button over there. Is it possible to show the data in web in some other fashion rather than using Power BI, like consume it from some API? Hmm. You have to deploy the API. Yes, totally possible. We can provide the location from where your API can fetch the data. Yeah, so that is totally possible. Okay, so should all the pieces of this architecture be available in platform as service solution? Will it be possible to have a hybrid model, PaaS plus IaaS plus PaaS plus on-premise? Okay, so uh, the we can have uh, we can have cloud plus on-premise. PaaS plus on-premise is another thing which we would like to suggest to them. That see, one of the problem which we are facing right now is that because of IoT becoming so popular, the amount of data which is getting streamed to some endpoints in the world in today are choking the internet because of the amount of data which is streaming. Internet is getting choked. So why? And definitely this will be this can also be translated into a delay. Like why should we send to cloud and then do the final processing there? Why can't we have a local job running here here and then send less amount of data, maybe some final aggregated output, or maybe for advanced analytics send some smaller amount of data to the cloud? Yeah, that is possible. This is next thing we would like to suggest to them. And unless they have a reason to use infrastructure as service, like maybe they are not happy with IoT Hub or Event Hub, uh, or are not happy in the sense like they want literally to log in inside the head node and run their own jobs or anything to do in that manner, then we will not be able to go with the PaaS solutions, and then we will request them to go with the IaaS solutions. and manage it yourself. You can also unmute and ask. So I can just see two more questions are there. Okay, so okay, now how do you basically how do you propose to price this offering? The efforts to integrate sensors. Okay, the so we will be doing. We have the capability of doing automatic sensor registration by using certificates as such. If possible, we would like to do that in their environment. Maybe because it's possible. Maybe they have some sort of sensor which is so, you can say, legacy, or maybe which came in the first when first many years back IoT first came out or first became popular, or the Raspberry Pi became so popular, then it is not supporting it, or and so on. So, but otherwise, would like to go for the certificate-based enrollment, and then the efforts are really minimized. Whenever the device gets connected to some sort of network, it will be registered with us, and we will be able to start managing it, reducing the efforts. That certificate-based enrollment is definitely what we would like to put back to them. Now, building custom model. Okay, now building custom model will definitely have uh, efforts, and will also require the team as well who can build the custom models and maintain it. And definitely we would also have to make sure that this model, when it is getting deployed, it just cannot go like that, right? The way we have done it, it basically we have to do the DevOps integration. But if we do that, it's gonna provide that incremental value to the end customer in those small cycles as such. So that adds value. It adds value to the way they are working. They may be working today. It adds value to the overall process. It adds value to the way in which we can get more requirements, and then incorporate those requirements during our sprints, and then provide value back in small cycles. If things go wrong, learn from it, and then make the changes. So the cloud components, uh, test validation definitely needs to be done. Uh, just imagine, in cloud we have so many ways in which we can integrate, which when done on premise also require us to manage the environments and the servers and everything. And that uh, the elimination of the capital expenditure, and moving into some sort of operational expenditure model will be useful for this company. There is one more thing which we would like to suggest to them, are the reserved instances. So when we are running something on Azure for, let's say, a period of for over a period of 3 years or maybe 1 year, then Azure gives more discounts on those solutions. So we can provide reserved instances. We can think of that okay, let's go to the cloud. You are getting more discounts, 60% more discounts, and so on and so forth, like that. There's a range of the discounts. So that can also be added over here. And this, okay. Now, the last question, if I can see, is will IoT Hub scale up and event streams distribute to respective partitions within that IoT Hub instance? Is it default behavior or something we need to enable it? Now, we have to enable, first of all, the number of partitions which we want. Once the number of partitions are defined by us, the count of partition doesn't change. So this is something which we have to think on day number one, like uh, how many partitions do we want? So like, do you want to work with 5, 10, 32 partitions? Event Hub even supports 100 partitions as such, like that. So, okay, if I can see if we can create one new one, and let's see if it shows us some more options. I'll just go one page back and see if I can show you some details over here. And let me zoom out first. Okay, so I'll create one more in that case. Okay, so I'm not sure how many partitions did I selected when I made it. I think it was I just left it default itself, so must be a smaller number. But yeah, we would like to know how many partitions we would like to go ahead with. Now, secondly, uh, the way the data is written is also important. Like if I specify, then it goes in the partition. If I don't specify, then it goes in round robin manner. So do I have a need around reading, writing into few partitions and then reading from it? Or will that round robin manner of writing data and maximizing all the partitions over there, uh, is that something I'm looking for? That also is what we can think of. On the right side of the diagram, there are some yellow boxes. Can we show the implementation of the same? Yes. Okay, so what we have done is, you see these microservices. So the old application which wide world importers had was developed in the monolithic approach. So what we did is, I'll just show that part as well, and I request you all guys to do that as well. I will just take the RDP of my VM because I did the setup inside the VM. So even if something goes wrong with my laptop and all that, it doesn't, uh, it will not matter that much. So, okay, now, okay, so I have installed Docker here. Uh, I have installed .NET 3.1, the old one, Docker, and Python is also there installed. Power BI dashboard desktop version is also installed inside this one. So now what we, okay, I think it everything got closed, but I will show you the commands which I have executed before. So I am just going to go to that GitHub link, and I'm just scrolling down to that exact step which I have. So I can copy the things from there. Okay, so check this out. Okay, so let me see if I can find it or not. So this is that .NET. This is one of the functions. We would like to see the microservices. So, okay, let's go down. All these instructions are there in the link which we have shared. So you guys will be having uh, all these steps over there, which you would like to go through. Okay, now, mm, okay, this is the Kubernetes part. Yeah. So uh, now there are two things which we have to do is, first of all, we have to build the images, and those images, and then we have to push those images in the container repository. So the microservices which we have are already provided to us. So that part physically, or that part is not, you can say, you will not be able to, you don't have to do it as such. The microservices are available, the containerization and the deployment and the configuration in the deployment is what we will be performing over here. So basically we have this Synapse, so we'll build these five images, and if you can see, uh, this is the ACR over here. So ACR is the repository for images. If I just take you and if I just show that once, that is where we have pushed all the images right now. So let's go to the RG and let's see if we can find it from there. And that's equal to Docker Hub. So you will be doing Docker push inside ACR, and let's find it. Okay, that one. And this is the, and let's find the repository. So all the Docker images are pushed over here as such. Okay, so these are the ones, and we will be doing that in the next step after that. So somewhere you can simply uh, do that. I'll just close few of the not required tabs right now. And let's find where that instruction is available. Okay. Now then specifically we have to specify this is where we are pushing it. So this is your ACR uh, FQDN. So basically, let's say my ACR is Shivam's ACR.azurecr.io. So this is where the push operation happens. And then we'll create this deployment file. So in this deployment file, we will specify all the details as such. And with this deployment file, we will deploy our microservices. So we are going to specify the ACR URL, username and registry, the passwords over there for ACR, which region, the name of the microservice, which is called as Innovate for Synapse, another image path, the third image path over here, and the other image path over there. So we are going to specify that query services, metadata write service, metadata read service, those yellow boxes which we had. Now, once this is done, this we have to apply. So to apply, we are using uh, Azure CLI to apply that. And it's just gonna create one RG and will just, RG may already be existing. It will just deploy that YAML file. And with that YAML file, all 5 or 6 of the microservices will get deployed in one step. This is what you will be doing over there. Okay, so I'll just go to the next question. How do you break the monolithic application into microservices? The domain-driven design (DDDs) which you are thinking of, there is a very nice, I think, even Vivek, I saw his post a few weeks back. They were discussing the domain-driven designs as such, and the logic behind how how do you identify, uh, let's say, how to break the existing application into microservice. So there are a few sessions from him as well. And if you look up in the architecture section of Microsoft, where we have so they have actually taken one example. They have taken the example of a drone application that, okay, so and then they have broken that drone application into microservices by going through the entire process. So it's a very nice documentation uh, for that drone delivery application. That's the example which they have taken, and I'm definitely sure there are more as well, and maybe in future we'll do one specific session for it. For choosing Event Hub partition to use or not, we decide based on the requirements, like we need to high availability or consistency. Yeah, partitions will be very specific to, and the problem is, once you specify the partition, you cannot change it later. Meaning, there is no way I can just edit it later on. So I have to think it from the starting itself, from here. So we have to specify the number of partitions we are looking for uh, as such. Otherwise, we have to deploy another event hub. So edit is not there yet. Okay, so this is this lab is this lab having all the codes and templates? Yeah, it is having all the codes and a template. Is it, can I deploy this on free tier? I am not sure, because in the free tier accounts, Azure free trial, we have 10 core quota limit in every region. So if I would have used any free tier, I could have reduced the number of cores I have given in all the locations. Like when we are deploying the model here, then maybe go for half a core, or maybe you can say some sort of a portion of the core, or maybe one core itself. So yeah, maybe some few errors may happen if you go for the free trial, but if you reduce the number of cores, maybe manually in the template or whenever you're doing the deployments, I think you'll be able to take it forth with some workarounds. Okay, so I just see the last question, that can you share the that drone delivery application? I'll just do that. Okay, anyone else? Anything which you have? Okay, this one. So this is just literally very to the point as such, but this is not the starting point. I have to go uh, back maybe here. Okay, so basically this is from where it gets started, I think so. And then some high level things over there, and then it goes into more details as such. So what is this DDD? How do you do the domain driven designs? How do you find the tactical patterns? What else do you do? Drone delivery patterns. This is what we were talking about, that there was a yeah, so this application is have we would like to break this application into having these specific services: account, package, scheduler, supervisor, delivery, confirmation, and this these are depending on that. So dotted lines were the asynchronous communication, the solid lines were the synchronous communications, or all those things are available on this page. So I'll just give you this page and you can navigate over there, and then this is pretty important. This is exactly what we would like to understand, the boundaries as such, that how do you differentiate between that, do I need another microservice for this functionality or not. So I will recommend you going through all those and then these, and then it further goes ahead. So I'll give you the landing page in the chat, have a look at that. Find me on LinkedIn. Just ping me on LinkedIn. We'll take that over there. Right. Okay. So I'll share my LinkedIn profile. I think the questions are now fading away. So the next session which we are doing is on which I'm doing. There are so many good sessions which are happening even before that. But the next session which I am giving is on is next week on PyTorch with and computer vision with PyTorch, and we'll be seeing the we'll be seeing the different architectures as such, including CNN and the little more advanced architectures of VIT, the vision transformers over there. So if you're interested, have a look at that and find me in the next session. I think it's on Tuesday.
Yes, Shivam, it's on Tuesday.
So I'll give the post training link again in the chat for all of you to bookmark as such. It's shared earlier as well. I'll just anyways put it again. And thanks everyone.
So we'll just give it another 2 minutes, Shivam, in case if people have any questions. And I have enabled the mic just in case if you like to ask any last minute question to Shivam. Otherwise, you'll find his social handle on the meetup page. Please do share your feedback about today's session and feel free to use the Learn module link, which is shared in the chat section. This will give you access to additional resources to take your learning further. Also, please visit our Microsoft Reactor Bengaluru meetup page for more upcoming sessions. Okay, seems like we don't have any other questions, Shivam. So thank you so much for today's session and thank you all for joining us today. Have a nice day. Thank you.
Thank you.
Thanks, everyone.
Thank
Thanks,
you.
all. Bye.
Thank you.